Hi everybody, today we're doing an example where we're given the cotangent of x and we're going to use it to find the cosine of 2x. In our example, we're given that the cotangent of x is 15 over 8 and it's located at quadrant 1. We're going to find cosine of 2x. The first thing we need to do is decide which of the three versions of cosine of a double angle do we want to use. We can use cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. I'm going to pick the middle version just because it only requires me to find cosine theta, not both cosine and sine. To use this formula, I'm going to need to know the value of cosine theta. I'm given cotangent of x. We know cotangent of x is the reciprocal of tangent, so cotan is 1 over tangent. That means I can flip 15 over 8 into 8 over 15 to find tangent of x. From here, I'm going to use the fact that I'm in quadrant 1 that tells me all of my trig values are positive, so I don't have to worry about the sign in this particular example. And I'm going to draw a small triangle. In my triangle, I want to indicate that x is my angle. I know the opposite of x is going to be 8. I know that the adjacent to x is going to be 15. I need to find the hypotenuse. We can use the Pythagorean theorem, which says h squared will be 8 squared plus 15 squared. We'll simplify that to get 64 plus 225, which is 289. The square root of 289 is 17, so I know that h is 17. Now that I have all the sides to the triangle, I can find cosine of x. It's equal to the adjacent 15 over the hypotenuse of 17. Let's take that value and put it into our double angle. This says cosine of 2x is 2 times 15 over 17 squared minus 1, which simplifies to 2 times 225 over 289 minus 1. That's 450 over 289 minus 1, or 169 over 281. We're going to stop right there. We want to have an exact answer as our solution, so I don't really want to make it a decimal. I'm going to leave the number in its rational form.